So I want us to grab our calculators on page 5, and I just want us to start graphing these for all these different functions actually. So I just want to make sure that we know how to type in certain ones. So let's just go, let's start on, well, we don't even need a graphing calculator for y equals x. How do we graph that one? Yeah, so we're going to start at the origin, and then we just have a nice slope of, what's my slope? 1. And we've got a perfect diagonal line. What about this one? Does anyone remember how to graph that in your graphing calculator, if we needed our graphing calculator? Does anyone remember in that y equals screen, math, right arrow, enter. That gets you the absolute value, and then go put an x in there. Math, right arrow, enter. If you don't have a graphing calculator, go get one. So this is going to give us a perfect little V starting at the origin. Let's talk about x squared, that basic parent function of x squared. What is that one going to look like? It's a basic, it's like a u, right? But we want the perfect points, you guys. So let's go back to your graphing calculator. And I'm only doing this just to teach us this, this trick. Let's go ahead and type in x squared on your graphing calculator. And then when we do, I want us to get perfect points. So you guys, I want us to plug in 0. So everybody hit trace 0, enter. Trace 0, enter. Trace is on the top bar. Trace 0, enter. What point does your graph have? 0, 0. And it says it right there. So I want us to all go plot 0, 0. Then we want to know what, when x is 1, what point is that going to get me? So I'm going to do 1, enter. You don't have to keep hitting trace, but what's 1 squared? 1. And then we can hit 2, enter, and it's going to give you these points, and I hope that we already know those, that 2 squared is 4. And what would 3 squared get me? 9. And if I hit -1 and I hit enter, so you can just hit trace once, and then you can just go be plugging in these x values, -3, hit enter, and then that'll get you these perfect points on this function. Let's keep it up. Let's go to this guy, square root of x. Let's go graph that. In our y equals screen, go ahead and hit second square root of x and graph that. And you might want to zoom 6 normal window. Square root of x, let's graph that up. And you guys, let's do that trace function again. Trace 0, enter. What point does the square root of x start at? 0, 0. And then if I do 1, enter, what's the square root of 1? 1. So I got the point 1, 1. If I do 2, I get 1.41, and I want this to be really accurate, so I'm not going to plot when x is 2. Do I know the square root of 3? 1.73? No. Do I know the square root of 4? Yeah, what's the square root of 4? 2. So I'm going to go plot that point. What's the next square root that I would know is a nice whole number? Square root of 9 is perfect. So that allows me to plot a perfect square root graph. So this one we know 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So let's go plot -1 cubed is -1 and -2 cubed is -8. Got a nice x cubed function. Cube root of x, you guys. Let's all go to our y equals screen. We need the cube root, and how we get that is we're going to hit math, and then option 4 is the cube root. Math option 4, cube root of x. Graph it. Cube root of x. Let's go get some points. I'm going to do trace 0, enter. This also has the point 0, 0. And then cube root of 1 is still 1. Cube root of 2, we don't know. Cube root of 3, not a nice decimal. Cube root of 4, cube root of 5. Nothing's going to have a nice cube root until we go to 8. The cube root of 8 is 2. When x is -1, we can hit -1, and it tells us we got -1. And again, when x is -8, we got -2. So the cube root of x looks like this. So now the 1 over x isn't quite as friendly. So let's go graph y equals 1 over x. 1 over x and hit graph. This one I do want to accurate, you guys. When we hit trace 0, do we get a point for that one? No, because there's a vertical asymptote. So we've got a vertical asymptote at 0. Maybe we throw that in there. We also have a horizontal asymptote when y is 0. And then let's go do, how about when x is 1? Ooh, that one has a nice point, 1, 1. How about when x is 2? What'd you get when x is 2? Yeah, 0.5 when x is 3. 0.333 is a third. When x is 4, we get a fourth. So that makes sense, right? Because we're doing 1 over x. Maybe we even want to do a 0.5. When x is 0.5, I get 2. 1 divided by half, same as 1 times 2. And then even if I did a third, 0.33333, or 1/3, I get 3. So again, this is just letting us see we've got this function that is hugging my asymptotes, vertical and horizontal. And that trace function, I think, is helpful to see. If I did -1, I've got a -1 over here. Bless you. And then again, it's just going to, bless you, get closer and closer to those asymptotes. Let's do something similar. Whoops. And let's go graph 1 over x squared. See how that changes the game. 1 over x to the second. Squaring things makes them positive. Let's see how it looks on that graph. Yeah. We're making them positive. All my y values have to be positive. So again, if I do trace 0, there's a vertical asymptote there. Doesn't exist. If I do a horizontal asymptote at 0 as well, when I do x is 1, I get 1. When x is 2, I get 0.25. Woo! This one's growing and shrinking quicker. When x is 3, I get 0.11. So we're just getting really close to those asymptotes. If I did x is 0.5, I'm going to get 4. Wow. This thing growing and shrinking even faster because we're squaring those values. -1, I get, 1 again. This is just going to be reflected over that y-axis. If I do a -2, we're at 0.25. A -3. If I did a -0.5, I'm at 4. So we're hugging and we are decreasing quickly. I love me some e to the x. You guys, let's go to our y equals screen. We're going to do second natural log. That's where we're going to get that e button. Second natural log, we're going to say e to the x. And we'll graph it. Let's plot some points. When x is 0, enter, I got 1, 0, 1. When x is 1, I got 2.718, 1, 2.718. I'm just going to estimate. And that is what e's value is. When x is 2, 7.389. Again, are we just estimating now? Yeah. 7.3. We're estimating, and that's totally fine. These irrational numbers will never come out nicely. When x is -1, I got 0.36. When x is -2, I've got 0.1. To me, that's enough points to know I'm just going to exponentially increase that function. Then I'm going to hug this horizontal asymptote of 0. Last one, we got natural logs. So we're going to go back to that y equals screen. And you don't hit second this time. We're just going to hit that ln button. ln of x and hit graph. Oh, and this is where our calculators sometimes are our worst enemy. Does anyone else's calculator cut off like mine does? Mm-hmm. Oh, yeah. Do you mind if I take a picture of that, Gracie? Because I think that's what everyone else is doing too. You guys, this is so misleading because the function actually isn't cutting off. This is really misleading. This makes you think that it is, but it's just hugging this vertical asymptote so closely. I'm going to put it in red. It's hugging it so closely that it would look like a vertical line, and our graphing calculators will never, ever graph a vertical line. Even though it's getting so close, it's not vertical, but it's not pixelated enough or HD enough to show that. So we've got to go graph this, and we don't want to just cut off our graph. So let's go say, trace when x is 0. It's going to say no, 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 because we got a vertical asymptote there. I agree with that. Let's go do when x is 1. What do we get when x is 1? 0. When x is 2, I get 0.693. 0.693. When x is 3, I get 1.09. When x is 4, I get 1.3. And you guys, I'm good with us just saying, I'm going to make my pen a little thicker. Just knowing this is getting really close to that y-axis, and then we're increasing this way. We don't want to cut off our graph like our calculator makes it look like it does. This goes on infinitely to the negative y values. So now as we shift to 8, this is, again, what we just graphed. We've got y equals 0 here. We've got y equals x. We've got that x squared. These are just these parent functions, x cubed, square root of x, absolute value. We don't need to worry about the greatest integer function. And then we got 1 over x. Okay, so we just practice those, and we got to get familiar with those. What that's going to lead us to is, hey, let's go do some transformations. And this is definitely ACT, SAT stuff that they're going to have us do. This is saying my original function was the square root of x, which we know is like this. Boop, here's the square root of x. It goes like that. And then what is this plus 2 going to do to that? Any ideas? What's that plus 2? Right 2, left 2, up 2, down 2? Up 2, because it's like my y equals mx plus b. So what that's going to do, you guys, is we're going to go up 2 on our y-axis. Boop, boop. And then we need to go graph our original square root function. So what this plus 2 just did is it's like it moved my origin up. And then at this point, I actually want us to stay away from our calculators, which is so annoying. I know. I want us to see if we can do it without, meaning we know a square root graph looks like this. I'm going to go back up here and erase what I just went over. That's my square root graph. And all this did is it shifted that graph up 2, right? So you guys, this is like my new origin. This is like my new 0, 0. So if we acted like this is my origin, and then I've already taken care of this plus 2, what's my square root of x going to get me if x was 1? What if I went 1 away? The square root of 1 is just 1. You're so right. You could think about it in terms of 3. I just think about, oh, I've taken care of this 2. Now I'm just shifting this graph up 2. You know what I mean? So then, again, if this is my origin, I don't know what the square root of 2 is, so I'm going to leave it. I don't know what the square root of 3 is, but 1, 2, 3, 4. If I went 4 to the right, what's the square root of 4, you guys? 2, and I'd go up 2, and that's my new square root graph, drawn nicely without using my calculator. Okay, what do you think that this square root of x minus 4 is going to do now that that minus 4 is in the square root? I'll let us use this just to see if I did the square root of x. Whoops. You're saying it's going to move it right 4. You're exactly right. The square root of x minus 4, it's like counterintuitive. It's taking it right 4, and you might be like, what? Why? Here's why. It's going to take us right 4. And the reason is, this is a 0. This is when does that graph cross that x-axis, is when does this equal 0, which you don't have to go through this, you guys. But if we had to figure that out, we'd square both sides, and we get x minus 4 equals 0 squared, and we'd get my x is positive 4. So that's why when it's in the square root or in the parentheses, it's going to shift the opposite way than we might think so. So now we've got the square root graph, which we know looks something like this. And now it's shifted right 4. So now I want us to draw accurately what the rest of that graph would look like. So if this is my new origin, I'm going to act like this is 0, 0. What's the square root of 1? 1. And I'm just going to say, all right, that goes there then. And then I don't know what the square root of 2 or 3 is, but I do know the square root of 4 is 2. And now I just have that exact same graph that I shifted right 4 units. Perfect. Okay, last one, then I'm putting it all together. What's this plus 3 going to do? Right 3 or left 3? Left 3. So if I were you, I'd write myself a little note. That's taking the left 3. What's my little minus 1 going to do? It's going to move it down 1. Well said. I think those little notes are helpful. So we're going to take my nice little square root graph. We're going to go left 3, boop, 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 and down 1. This is my new origin, you guys. That's my new origin. This is 0, 0. And then we can just treat this like a normal square root graph. Square root of 1 is 1. Square root of 2, I don't know. Square root of 3, I don't know. Square root of 4, 1, 2, 3, 4 away is going to be up 2. And here's my graph. Okay, we can skip that part. Let's flip it. Okay, through 7, and we're good. So on these top ones, this basic graph, is the cube root of x. Boom. This is the good old parent function cube root of x. What did they do to my cute little parent function in part A? What do you think they did from the original? They shifted it up 1. I love it. So you just said, oh, they just did plus 1. So it's going to be the cube root of x, and then we're going to just go boop, boop. We just shifted it up 1. And maybe you write yourself a little note. That one was just moved up 1.
Is that outside of the...
It is outside. That's a good call. Left and right would go under the cube root. Very good call. Oh, what about this one? Where did they move that? Here's the okay, let me put this in red. The origin was here. We just saw here that they moved it up 1. Now they moved it this way. Yeah, so we got a cube root, and we got to do x minus 1 under the cube root, because you're right, we went right 1. But how are we going to get it from going up from left to right to down from left to right? Any ideas? So whenever we've got to change the directions, instead of it going from left to right, it's going up. If it's going down, we just need to negate the whole thing. So I'm going to throw a negative right out front. A negative cube root. It's not supposed to be with that 3. Like, technically, my little negative should just be out front. Let me write it with a little bit more space. Negative cube root of x minus 1. That's how I'd write that. Okay, final one. You with me, Thomas Drew? Here we go. This origin's now over here. How are we getting it over here? Which way did it move? Left 2 and up 1. So how are we going to do that? Cube root of x is my ridge. How am I going to get left 2? X plus 2 is going left 2. And then how am I getting up 1? Throw a plus 1 outside of that square root. Yeah, I think we can end on that. We're good.